Alright, so in this video, we'll take a look at some real world application of trigonometry itself, how we can apply sine rule to actually help us solve problems in the real world context. Okay, so in the diagram, PQ are 2 points 400 centimeters apart. So as we read the question, let's check the diagram. Point is correct, it's given there. Okay, on the ground, H is a horizontal vertically above point R. On the ground, angle HPR is 37 degrees, HQR is 60 degrees, and angle HRP is 90 degrees. So all is given. Find the distance HQ. So let's highlight the distance identified. Okay. So you realize that on first glance, it's not that obvious what I need to do. Okay. But you realize that since I can easily find this angle over here, okay, which is 180 minus 60, which is 120 degrees. So let's just do that first. So angle HQP is equals to 180 degrees minus 60 degrees equals to 120 degrees part A. Okay, and if you want to be very perfectionist, you can always just put that adjacent angle on a straight line. All right. Now, of course, we still have not enough information because you can't exactly find, but realize that this is simply our case one, two angles and one side. So definitely I can find a sine rule. So let's just look. Okay, this angle, this side corresponds with this 37 degrees. Okay, the only other known, the only known length that I have is 420, which corresponds with this angle over here. So is there a way that I can find this angle over here? You realize I can just use sum of angles in triangle. In fact, you can actually skip this step over here. You can actually use what do you call it, exterior angle of triangle. Okay, but I know a lot of you tend to forget that step itself. So let's just do this the wrong way. So angle PHQ is equals to 180 degrees minus 120 degrees minus 37 degrees, which is equals to 23 degrees. Okay, and the reason is simply sum of angle in triangle. Okay, now let's just quickly show alternatively. Okay, you can just take angle PHQ equals to 60 degrees minus 37 degrees equals to 20 degrees, reason being exterior angle of a triangle. Either way, it's fine. Okay, so now that I have this angle as 23 degrees, okay, and this corresponds with 420, and I want to find HQ, and I have the corresponding angle that corresponds to HQ itself, I can easily use sine rule itself. So HQ over sine angle QPH is equals to PQ over sine angle PHQ. Substituting all the numbers, so HQ over sine QPH is 37 degrees, so sine 37 degrees equals to PQ. PQ is 420 over sine PHQ, so PHQ is 23 degrees. Okay, so multiply throughout by sine 37, I have HQ equals to 420 over sine 23 degrees multiplied by sine 37 degrees. Okay, and I will evaluate it. So HQ is equals to 646.90 meters, 5 SF, and of course round off to 3 SF, 647 meters. Okay, so just label it here 646.90. Alright, so that's for part A. Let's look at part B. Part B is asking you for the height of the helicopter above the ground. So basically I'm looking for this height over here. And you realize that over here, to find this particular height, it's actually a right angle triangle. Okay, so now in this case, we don't have to resort to using sine rule, because I already have my hypotenuse, which is this length over here that we found in part A. We have an angle over here, and corresponding to this angle, this is your opposite. So we know for a fact that for part B, using your Tuakaso, sine 37 degrees is equals to opposite, which is HR over HP. So sine 37 degrees equals to HR is what I want to find. HP is already given in the part A, 646.90. So multiply by 646.90 drop, HR equals to 646.90 multiplied by sine 37. Okay, and I will get myself 389.32. 31, sorry, and then round off to 3SF, 389 meters. So the helicopter is 389 meters above the ground itself. Okay, so if you want, you can just write down a statement to answer the question. So the helicopter is 389 meters above ground. So now what we have done in this example is you realize that we don't just use sine rule to solve questions with regards to triangle. We can still use your Tuakaso. Okay, of course you can still use a sine rule, but it's quite, I think, long-winded if you do the working. Okay, so you realize that as long as I see a right angle triangle, I still can use my Tuakaso, I still can use Pythagoras theorem, even though I have learned sine rule, and later on, even though I've learned cosine rule. Okay, so that's it for sine rule. I hope you understand. If there's any questions, do drop me a message. If not, do enjoy the practice that you have been given or assigned to in class.